Our final lesson in topic 2a is called factored form. This is the last type of quadratic function we'll look at. Notice we have lots of objectives. We can do a lot of things when we're done with this lesson. That's why we're splitting it up into 2 days. When we talk about factoring, the first thing we look for is called a common factor. A common factor is a number or variable that all terms have in common. We always check for a common factor first. Let's try some examples on the right. Factor the expressions. Our first expression is 4x minus 20. That would be a linear expression. We look at both terms. We've got two parts here. The 4x is a term and the 20 is a term. If we try to look for what both terms have in common, we look for what both goes into both 4 and 20, and that would be 4. If we factor that out, it's a product of smaller things. 4 factored out of 4x is like division. We would simply have x left over. Then it's a subtraction problem. If we factor 4 out of 20, 4 goes into 20 5 times. That's called factored form, factoring out a common factor. It works for variables too. Let's try the next one. X squared plus 15x. Again, the terms are separated by addition or subtraction. There are two terms here, and they both have an x in common. Therefore, if we factor x out of both of those terms, taking x out of that x squared, we would have an x left over. And if we take x out of 15x, we have 15 left over. That would be the factored form of x squared plus 15x. The last one, 9x squared minus 81x. Notice here we have two terms again, and we have numbers and variables that both terms have in common. For the 9 and the 81, the biggest number they both have in common is a 9. And x squared and x, just like that last example, there's an x that they both have in common. If we factor 9x out of 9x squared, we would only have an x left over. If we factor 9x out of 81x, 9 goes into 81 9 times, so there'd be a 9 left over. And x goes into itself, and there'd be no variable left on the inside of that parenthesis. When you're asked to factor with more than two terms, and if possibly there isn't that common factor, we look at the types of groupings that we have. In the next row, we have 3 terms, and notice our x squared each time is the same. There isn't a number in front. If there isn't a number in front, that means it defaults to 1. And our plan is find factors of c, that constant at the end, that add to get b, the coefficient in the middle. When you find that, you're going to split it into a product of smaller parts, and you'll split the x squared into x times x. And then we'll have things written in the second part of the parenthesis. All right, let's try that. That sounds like a lot of work. In our first example, we have x squared plus 7x plus 12. Notice for our x squared term, there isn't a number in front, so it defaults to 1. That means we're going to go for factors of c, factors of 12. Well, there are lots of factors of 12. We could do 1 times 12. We could do 2 times 6, or we could do 3 times 4. All 3 pairs are factors of 12. And then it says add to get b in the middle. So out of those 3 pairs, is there a pair that would add to get 7 in the middle? Well, if you think to yourself, well, 3 and 4 add to get 7, you'd be right. That's the pair that works for both. Once you know the pair, we split the trinomial, the 3 terms, into a product of 2 parentheses. That x is going to split apart into, the x squared splits apart into x times x. Since the 3 and the 4 are both positive, and we want positive 7 on the inside, we literally just write plus 3 and plus 4. Notice x plus 3, there isn't anything else that has in common, and x plus 4 doesn't have anything in common either. That is the factored form. If you wanted to check it, you could always FOIL those parentheses. So we could FOIL to check. Here's what I mean. If we take x times x, we'd have x squared. X times 4 would be 4x. FOIL the inside, the 3 with the x is 3x. And the 3 times 4 would be 12. To simplify, combine any terms that are like terms, and we do in fact end up with x squared plus 7x plus 12. So we know that this is in fact the factored form. Over on the right, x squared minus 2x plus 4. Let's see if we can factor this one. There isn't a number in front of x squared, so that defaults to 1. That means we split the c. 4 breaks down into 1 times 4 and 2 times 2. So now we have to try to figure out how can we get negative 2 in the middle. Well, 1 plus 4 or 1 minus 4 would either be 5 or negative 3. 2 plus 2 is 4 and 2 minus 2 is 0. So neither pair works. If you can't get a pair to work, we would say that it doesn't factor. So look out for that. Sometimes that might in fact be the case. For our last example, would you please change negative 18 to positive 18? Now we have p squared minus 9p plus 18. Just like before, the coefficient in front of our squared term should be 1. So we're going to split the c value, 18. 18 has lots of factors. We could do 1 in 18, 2 times 9, 3 times 6. All of those pairs work to get a product of 18. Now, we need to figure out how to combine them in a way to get negative 9 in the middle. Well, positive 3 times positive 6 gets you positive 18, but not negative 9. If we change their signs to negative 3 and negative 6, when we multiply them, we'd still get positive 18, which we need, but then we need to get negative 9, and that's what we'd get when we combine like terms. Once you know your pair, we're going to split it into our two parentheses. And now instead of x squared, we have to break apart the p squared. So it'll just be p times p. Since we have negative 3 and negative 6, it'll be p minus 3 and p minus 6. And you can actually write those in either order. That part doesn't matter. It's interchangeable. When the a value is a number that's other than 1, we've got quite a list of steps to follow. It says check for a common factor first. So always look for that when you're factoring. If a is a number other than 1, what we need to do is multiply a times c together and get a new value. Once we get that product of ac, we're going to factor it or split it to get b in the middle. So it's kind of like what we did up above, but a little bit more challenging. Once we figure out our two numbers that get that b in the middle, we split that bx term. So in that term, or in that quadratic function that has 3 terms, we would now get 4 terms. And then we look for common factors again. I know, that seems like a lot, but once you see a couple of examples, hopefully it'll make some sense. Let's try our first one. It says 5x squared plus 35x plus 60. If you look at that, we've got 5, 35, and 60. 5 goes into all 3 of those numbers. That would be our common factor. If we take 5 out of all 3 terms, we're left with x squared plus 7x plus 12. Now notice the x squared term doesn't have a 5 in front of it anymore. It just has 1. So now we can split the c to get the b. And we've done this one already. This is 3 times 4. We'll keep that 5 out in front, and we'll split our two parentheses. The x squared breaks down into x times x. We want positive 12 when we multiply and positive 7 when we add. So that's just going to be plus 3 and plus 4. 5 times x plus 3 times x plus 4 is our factored form. Let's try the next one. 2x squared minus 5x minus 3. Notice we've got 2, 5, and negative 5 and negative 3. I'm just trying to give myself a little bit more room. In this example, we don't have a common factor. So now we need to go to that step 2. We're going to multiply A times C. I'm going to circle A and circle C. And I'm going to connect them. So it kind of looks like a pair of earmuffs, which is really silly to say, but it's a nice way to remember it. And then we multiply. 2 times negative 3 is negative 6. That's the number now that we split or factor to get B. For 6, we could do 1 and 6 or 2 and 3. Those would be our choices. So here's the unique thing. Technically, they both could work to get negative 5. But we need to figure out how can we get negative 6 when we multiply, but negative 5 when we add. So if we did positive 1 and negative 6, when we multiply them, we'd get negative 6 as a product, and when we add them, we'd get negative 5. That's actually the only way this will work. 2 and 3, we wouldn't be able to get both negative 6 when we multiply and negative 5 when we add. So now what we do, and this is kind of the tricky part, so I'm going to drop this down here a little bit to give myself a little bit more room. It says we split the bx. So what we're going to do is actually write this as 4 terms instead of 3. I'm going to start off with 2x squared. I'm going to keep that first term as is. But if I split the b in the middle, what that means is I'm going to use the 1x and the negative 6x. So I'm going to write plus 1x minus 6x. That's splitting the bx term. The last term was minus 3. Notice we made 4 terms instead of 3. And now look for common factors. To do that, I'm going to put a parenthesis around the first 2 terms and a parenthesis around the last 2 terms. That's known as grouping. In that first parenthesis, we have 2x squared and 1x. So they have an x in common. If you factor that out, we'd have 2x left over for that first term, and then 1 left over in that second term. In the second parenthesis, negative 6x minus 3, we have to factor the negative out to make the x positive, and for 6x and 3, we could take out a 3. If we take both the negative and the 3 out of negative 6x, we'd have positive 2x. And if we take negative 3 out of negative 1, negative 3 goes into negative 3. Negative 3 goes into itself 1 time. So we have a placeholder of 1 left over. Here's where we check our work. If the parentheses are the exact same, then we are in our final step. We're ready to write our answer. When the parentheses match, that means that's one solution for our factor. To get the other part of our factor, we just take the 2 terms on the outside and we combine them. It's either addition or subtraction. Since it's x and negative 3, that would be subtraction, x minus 3. So it takes a little getting used to, but that's how you create the factored form for a quadratic function when a isn't 1. Let's try one more. Take a look at 3x squared minus 7x plus 2. Notice our coefficient in front of x squared is not 1. Do we have a common factor? 3x squared, 7x, and 2? Nope, there's no common factor either. So we're going to have to multiply our a and our c together. Again, 3 times 2 this time would be positive 6. So now we need to break down numbers that multiply to get positive 6. We could do 1 and 6 and 2 and 3 again. We need to figure out some way to get negative 7 in the middle. Well, 2 and 3 are going to automatically be out for sure. But to get negative 7, we'd have to make both the 1 and the 6 negative. And that's our pair of factors for that bx in the middle. So now let's split the whole thing. We're going to keep our 3x squared. And then we split the bx in the middle, negative 1x minus 6x. That would give you negative 7 in the middle. And then we add 2. From here, we're going to group the first two terms and the last two terms. And then we try to factor. In that first parenthesis, 3x squared minus 1x, they each have an x in common like last time, so let's factor that out. We would have 3x minus 1 left over. In the second parenthesis, again we have a negative with the x, so we're going to factor that out. And for 6 and 2, they only have a 2 in common. So I'm going to factor out the negative and the 2. If we factor negative 2 out of negative 6x, negative 2 goes into negative 6 positive 3 times, meaning we'd have 3x left over. And if we divide 2 by negative 2, that goes in negative 1 times. Again, here is where we check our work. We're in good shape right there. The parenthesis matches. That means that's one of our answers. The other answer comes from the parts on the outside, x minus 2. And again, if you wanted to check your work, you could FOIL. And if you combine like terms, you would end up with 3x squared minus 7x plus 2. And that's the first part of factoring for 2.3.